So today we are covering our final set of notes for the semester over imaginary solutions. So now that we know what imaginary numbers are, if we end up solving a quadratic and we have a negative inside of our square root, we are no longer going to say no real solutions, because while that is true, the answer is actually a little more complicated than that. Because we have no real solutions, that means we do have imaginary solutions. So if you end up with a negative radical, I want you to tell me the imaginary solutions. And we're going to do some examples of that. Remember, I is the square root of -1, and here's our quadratic formula in case you forgot, but that is something you want to get memorized. And we're just going to do 4 problems. The first 2 are quadratic formula. The second 2 are completing the square. So let's jump into number 1. If I'm going to use my quadratic formula, I need my equation in standard form. So I'm going to move the 28 over to the left. Okay, now that everything is on the same side, I can identify A as 1, B as 8, and C as 28. And I can plug everything into the correct location in my formula. So x is going to be -8 plus or minus the square root of 8 squared minus 4 times 1 times 28 over 2 times 1. So the first thing I want to do here is calculate my discriminant, the number inside my radical. So 8 squared minus 4 times 1 times 28. That is going to give me the square root of -48. So I have a negative, which means I'm going to have imaginary solutions. So I want to rewrite that radical in terms of I. So that's going to be the square root of 48i. And 48 is not a perfect square, but I can simplify it because 16 is a factor of 48, and 16 is a perfect square. So -8 plus or minus 4 square root of 3i is the simplified radical. And now the last thing I'm going to do is simplify. -8, 4, and 2 can all be divided by 2. And I'm running out of room here, so I'm just going to put the answer up above. But my final answer for this problem, number 1, is -4 plus or minus 2 square root of 3i. All right, same process on number 2. I want to use quadratic formula, which means I need standard form. So I'm going to move the 85 over. And now I can identify A is 4, B is -36, C is 85. So x is 36 plus or minus the square root of -36 squared minus 4 times 85. All of that over 2 times 4. Again, I'm going to calculate my discriminant next, the number under my radical. 36 squared minus 4 times 84 is going to give me -64. So again, I have a negative, which means I want this in terms of I, and this one is actually a perfect square, so it's going to be 8i. And then once again, I can reduce 36, 8, and 8 by the common factor of 4. And so 9 plus or minus 2i over 2 is my final solution. All right, just 2 more, and on these 2, we are going to be completing the square instead of using our quadratic formula. So starting with 3, the first thing I do is move my constant to the other side. And now I need to find the number that's going to complete the square. I do that by halving the middle term and squaring it. Half of -14 is -7. -7 squared is 49. So I'm going to add that to both sides. Factor my trinomial, and that's going to be equal to -1. So I take the square root of both sides, and I'm going to get that x minus 7 is plus or minus. The square root of -1 is I. So then I just move 7 over. And I have 7 plus or minus I as my solution. Okay, let's look at number 4. Same process, I'm going to move my constant over. And then, because on this one, A is larger than 1, I need to divide everything by A, which is 3 here. And again, I need to complete my square. Half of -4 is -2. -2 squared is 4. So I'm going to add 4 to both sides. So factor that, x minus 2 squared is -5. Square root both sides. I want this in terms of I, so x minus 2 is going to be plus or minus the square root of 5i. Move the 2 over, and my final answer is 2 plus or minus the square root of 5i. Okay, so imaginary solutions. Just rewrite it in terms of I, no more, no real solution is acceptable on your tests, quizzes, etc. And that is it for our notes today and for the semester.